Yes.
So this is question 3. So our K is -6. That is the answer. That is,
Okay.
so the first thing is use the formula for the gradient, then use those points to substitute. When you substitute, we are going to have numbers throughout. The only letters that we have is K, K, then so for K, as the question tells us.
All right.
Are we done copying?
Yes.
Any issue? You were Kimpande. Where's Kimpande?
Is here.
Oh, now Zinky man.
Why isn't he speaking for himself? Gideon is the spokesperson today.
Gideon,
Say something.
Makambi, see such a
You.
Where's Sam? Okay.
Yes, yes, I will. Okay, we'll go to question 4. Question 4 is factorization. Any issue with it,
No.
Sankanaji?
Can't we? Oh, yes, Anna's got a question.
Where's Anna?
She's here.
Jesus, that's why network ya should be down.
Yeah. One.
Question 4, we have a x squared y, and then minus a, minus 4, and then a y squared. Y power 3. Now, when they quite, when they say factorize completely, all you gotta do here is when you look at this, it must be of the form a squared minus b squared, perfect squares. That's what you're supposed to do. But looking at what we have here, these are not perfect squares. So the only way we're gonna make this be a perfect square is by factoring out that which is common. What is it that is common here? We have got a here, we have got y. So when you take out a and y, what remains inside? It's a x squared minus 4y squared. And you see that what you have inside the bracket is, these are perfect squares. But this 4 can also be written as ay and then x squared minus 2 squared y squared, that so that we're going to have perfect squares inside of the bracket, which are going to factorize it completely.
The y in the bracket is supposed to be plain.
Plain. We have 1 here, and here there are
Isn't
2. Here there are 3.
yes.
So when you take out 1 y, you're going to have 2 y remaining.
Oh yeah.
There were 3. So now once we have this, we're going to put this outside the bracket. We're going to have ay, then it is also going to have brackets here. Kizacho sako mapowers tureranda kune chinyanja vambiri mitavofetsungu, especially Anna. Kizacho sako mabrackets aya tisaviremba mabrackets, one of the brackets we are going to change the sign to be positive. So once we remove the powers, we're going to have x to y, x to y. Now we can decide which one to be between the 2 brackets. You can decide which one gets a positive and which one gets a negative. But according to my own preferences, nizafaka negative hapa, then nizafaka positive hapa. We are done. So when they say factorize completely, you need to look at the nature of the question. Are you going to use factorization by perfect squares? Are you going to use factorization by product, sum and factor? Or are you going to do the factorization by grouping? You have to look at the question which has been given.
Sir.
Right.
Yes.
Here, sir, when you're here, when after on the second step, you said ay brackets x2
minus
4y squared.
Yes.
Isn't it that the square is supposed to go because you put y here outside the bracket? So there's only supposed to be y, not y squared.
Can you see what we have within the question? The question is raised to power 3, meaning mawai are tatu. There are 3.
Oh, it's raised to power 3, not 2.
Oh,
Oh, so man, it looks like
it is raised to power 3. The
Sorry.
moment you remove one
yeah, it
y,
looks like a 2, sir.
get out.
That's-
Anyway. The moment you remove one y, they're going to remain with you. Okay. Oh, it was
Oh,
not.
wonderful.
Okay, let me put a power 3 so that your neck. Yaoneka manjika?
Yaoneka.
Better.
It's a
Okay.
3, it's no longer a power.
I was just trying to enlarge the power 3, which you could not see.
Yeah, I know.
Brandina, the question that we were talking about the other day about vectors which leads to collinearity, addition and subtraction comes on question 5.
Yeah, yes, I've seen.
So anyway, I'm recording the screen in case those that would want maybe to go back, I can resend back the video. So question 5 is talking about addition and subtraction of vectors. But one thing you need to understand is the movement. Please, Mwevant, movement. Osaivala. Don't be like me who got okay. Please, let's not forget. Question 5 is talking about addition and subtraction of vectors. When you are told that this is point P and this is point Y, you are going that way. If the point here is 4 and the point here is 8, when they say find PY, they are saying find the size of, moving from P going to Y, find the size of the line, because these are vectors. Supposed to have the size, the magnitude, as well as the direction in which it's going. So when you say that, you are going to say finding the size of this line from P going to Y, you're going to say Y minus P, which is supposed to be 8 minus 4. That is what it means. So when they say find we are given P and the Q as the vectors, as column vectors. We are given, so question 5, we are given P to be 2 and 4, but be reminded that this can also be written in that form because these are column vectors. And then Q, we are given that the point Q is -3, 1. These are column vectors, can also be written in that way. So when they say express PQ as a column vector, what they mean is say Q minus P. That is what it means. But the column vectors we're going to use are these. So in short, we are subtracting. What we have on Q? What we have on Q is -3, 1 here. Then we take away 2 and 4. It has even now gotten easier because this means -3 minus 2. -3 minus 2. Then 1 minus 4, which is 1 minus 4. And when we subtract these, -3, -2, we are going to have -5. 1 minus 4 minus 3. So that is how you can express it. PQ as a single vector, as a column vector. When you are given, yes.
So she's gonna say, wait.
You told me to wait and I'm waiting.
Basically, someone was talking in the background.
Oh, sorry.
So I was saying here, first, every time when solving this, like when you're finding this, you're always supposed to change these two into the inverse. Is it defined in the inverse?
We are given, look at what you are given, what you are given are coordinates. This is how you write coordinates. Point on the coordinate is X, Y. But now we are told to find the answer in form of what? In form of a column vector. And how do you that? Instead of having them as coordinates, you have them now as the column vectors. Because this is a column, that's how you say in matrices, a row and a column. So when you have coordinates like
Yes.
that, you have to write them as the columns. Then P
All right.
moving from P going to Q, so we're going to subtract P from Q. Are we okay?
Yes.
Yeah.
Question, anything on question 6?
Yes.
I can wrap. I'm saying anything on question 6, it's okay, you can figure it out. Sankaran,
No.
you didn't write?
No, I've written.
Yes, I have written. So
If.
I'm saying on question 6, do you have any issue or we go to 7?
We got to 7.
Anna, my friend, are you okay?
He's
Okay.
not there.
Sir,
She's
you can just explain, sir.
What I say?
Yes, I'm good.
Anything on question? Anything on? Let me just turn on the light. Anything on question? Anything on question 7? Is there any need for it?
No.
You said
no, Ferdinand, that's what we're solving.
Without doing
Yes.
question 7, are there any needs? Is there any need for question 7?
at yes,
A or B?
I think B only
yes,
because
B.
A is.
Okay. So
No.
B
Question
is
is
okay.
transport.
Okay. So question 7, we are given that A is equal to A is 3, 2, 1, and then we have 4, 3, 0. These are rows, and these are columns. So when they say find A transpose, what it means, let these rows become columns. These rows must become columns, 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 and then these columns must become rows. So the thing is, how many elements do you have in the first row? How many elements in the first row? 1, 2, 3. So meaning the first column must have the same one. We are going to have 3, 2, 1 because these were rows. Now they have become columns. Okay. The second row we have 4, 3, 0. We have transposed it.
So I have a question.
Yes.
So is this a 2x3 matrix or it's a 3x2 matrix?
This is the order is determined by row by column. So how many rows are there? 1, 2. The rows are 2. By how many columns? 1, 2, 3.
I was counting the first one. I was doing the second one.
So it's 2 by 3.
Oh.
And then so we are remaining with about 8 minutes, 8 minutes. Then B is talking about now multiplication of matrices.
What? The Zoom class ends.
Then you send another.
Then you send another.
Which other one? Just this one ends, I go and sleep.
So I've got a question.
Yes.
Let him finish.
Kimpande. Yo, Gideon.
Like when finding the transpose, aren't you just supposed to flip them? Why is the 430 at the other end? Isn't this
the row must become the column?
Yeah.
So we had D3, we had D430 as a second row. So it must be in the second column.
Oh, okay.
We had the 4, 3, 0 as the second row. So it must be 4, 3, 0 in the second column.
Oh, okay.
Then multiplying, we are multiplying A and B. So our A, but know that AB is not the same as BA. Let's hope you understand, because this cannot be multiplied, According to the matrix we are given, the matrices we are given, BA cannot be found. Only AB can be found. So what is our A? Our A is 3, 2, 1, 4, 3, 0. And then we are multiplying with the 1, 2, 3, 3, 2, 1, 0, 1, 0. So what we are going to do here, we're just going to do a simple multiplication, and you know how it is done. It is row by column. So what we're going to do is, the first row here, we're going to multiply 2 times 1, or 3 times 1. So we're going to multiply these ones here with that. The same one with that. The same one with that. Then we come to do this one with that. This one with that, this one with that. So the first row, we have 3 times 2. Oh, 3 times 1. So what is 3 times 1? 3. Plus 2 times 3, 6. Plus 1 times 0, 0. For as long as you are still dealing with the same row, you're still dealing with the same column, you need to add them. The only time when you leave a space is now when you go to the second matrix, or when you go to the second column. That's how it is done. So because this is the same row, same column, we're going to add them. 5 minutes. So now again we start 3 by 2, which is now I'm getting to the second column. That's your space. 3 by 2, which is 6, plus 2 by 2, 4. 1 by 1, that is 1. Again, is that your space. I'm going to the second column. 3 by 3, 9, plus 2 by 1, that is 2, plus 1 by 0, that is 0. I am done with the first column. I go to the second column. I'm done with the first row. I go to the second row. 4 by 1, that is 4, plus 3 by 3, that is 9, plus 0 by 0, 0. I'm done with the first column. I go to the second one. 4 by 2, that is 8, plus 3 by 2, that is 6, plus 0 by 1, 0. I'm done the second column. I go to the third column. That's your space up. 4 by 3, 12, plus 3 by 1, 3, plus 0 by 0, 0. Then I add 3 plus 3 plus 0, that is 9. 6 plus 4 plus 1, that is 11. 9 plus 2 plus 0, that is 11. I'm done there. 4 plus 9 plus 0, 13. 8 plus 6 plus 0, that is 14. 12 plus 3 plus 0, that is 15. We are done. So you start the first row, first column, leave a space. Second column, leave a space. Third column, you are done. Click on the second row, first column, space. Second column, space. Third column, space. Then just add them up to get to a resulting matrix. Are we okay? Are we okay? You know the rule, you unmute the camera. If you're okay, we go to the next one. If you're not okay, you let
Yes.
me know which part I should label on.
Okay.
We go to 8, question 8. In the remaining 2 minutes, I can solve A. Can I rap?
Yes.
Yes.
Rakimpandeni, shivet tamipikile tamride. Nsara.
Sir. That's fine.
Mwache exam taifa iko kumfensara.
You can use AP.
Paper fast.
So we go to 8, 80, we're gonna do A, then we go to B, we are done, we sleep, we wait for the exam. So in 8A, we are told to find the formula for the expression. We have 25, we have 22, we have 19, then we have 16. So this is our T1, this is our T2, this is our T3, our T4. And we know that our T1 is also the A. So finding the formula for finding the nth term, we say T nth term is equal to A plus n minus 1, then D. Our D is a common difference. How do you find the common difference? Common difference is found by T2 minus T1. Our T2 is 22. So it's 22 minus our T1 is 25. And because we are subtracting a bigger number from a smaller number, our D is negative. So having found the D there, we are just told to find the expression. We are not solving. We're not finding the answer. We're just told to write an expression. So we're told to find the expression for nth term. So Tn is going to be, our A is the same as the first term, which is 25, plus our n is the nth term. It's n minus 1, then our D is negative 3. It's the nth term. So we're going to have 25 plus n times negative 3. We are going to have negative 3n. Then negative times negative, which is positive 3. But the 25 and the 3 can be added. So once we add that, we're going to have 25 plus 3, we're going to have